Okay, so hi, I'm Josh. I'm looking at the Scalable User Simulator here. So this is a little bit of context. I'm a third-year cybersecurity student. I'm the president of the WMG Cyber Society, and I started working on this project in December 2019, so a couple of months after I started here at Warwick. So the customer came to us at the CSC and was like, can you create an application that could generate synthetic machine traffic? Now, network traffic, that's not too hard. There's tools out there, like I believe Cisco has one, where you open up browsers, you just start sending traffic. Sysmon logs are a little bit harder. So a little bit of context, Sysmon is a Windows service that looks at tracking kernel events. So on the left here, there's a very blurry example of a process being created. And Sysmon will log process creations, file reads, file writes, all that sort of stuff. So they wanted to know whether it'd be possible to build an application which could synthetically generate these and that would better mirror human behaviors when using a computer. So their use case is that they're building machine learning tools that take baseline Sysmon readings and for use in anti-malware. So whether they can detect malware earlier on before it gets too bad. So the problem is that they need a lot of data for this. Businesses are not too keen on giving out all of their Sysmon logs because of GDPR, business restrictions, all that sort of stuff. So yeah, so the general idea is that can we build something that makes this and makes it look as realistic as possible for use in training these algorithms. So a little bit about the architecture of what we ended up with. So we have a server and multiple clients. So the whole idea is that we can clone one of these VMs down here. So these are all Windows VMs. We can clone these VMs to the point where we can get 1,000 VMs running at one time, and they're all just generating Sysmon traffic. So the SUS server, it's got a front end attached to it, but it's responsible for collecting all of these Sysmon logs. There's also SUS logs, which is basically our baseline truth of we know that our program clicked on an email, so we can then use that to cross-reference with Sysmon logs. So for example, if our SUS logs say, this user clicked an email with a PDF attachment, we should expect to see that in our Sysmon logs, Adobe Acrobat has been started, the downloaded attachment has been read from, and so on. And the client, so fetches a schedule from the server. I'll go into a little bit more about what that means in a minute. But they log into the Windows machine, and they actually log into the Windows machine as if they were in front of it on the keyboard, which is incredibly hard to do because Microsoft isn't a huge fan of you running arbitrary code on the login screen. So being able to fake those actual keyboard inputs in the login screen is very interesting. Run applications based on the schedule and then report back to the server with all these sort of logs, whether everything went okay. So these are the applications that we built into this. It's very much extendable, but they were looking at small to medium enterprises. So you've got your Word, Excel, Outlook, and traditional sort of office applications. Browse websites. PowerShell was something that we added very recently, and that's because PowerShell is very commonly used by system admins. So if you're training a machine learning algorithm that never touches PowerShell, the second it sees PowerShell, it will fire and be like, something's wrong, when in reality PowerShell is used a lot. Adobe Acrobat, PDFs obviously very common, and Paint and Notepad, sort of fun ones that were sort of proof of concepts back in the day. So we have sort of general profiles here. We can see where we can assign sort of first name, surname. We have profiles such as research and development, HR, and these are used for tracking which VMs should log in with which user accounts. So for example, we have a client subnet, we have a HR subnet, research and development subnet, and they're used to determine what user should log into what machine. We also have a personality traits, and you can't see all of them there. This project, I believe, was originally done in collaboration with the psychology department. So they were looking at how could you classify people to show how they interact on the internet. So originally we used a Reddit comment database, and these personality traits would determine what comment we would use from Reddit. So one of them is anger, for example. So if they had a high anger rating, then they would send offensive Reddit comments to their friends and family. But it's not so much used now, mostly because the lecturer who originally started this project disappeared to Cardiff. But hey ho, we're still here. But yeah. So we have tasks. Tasks, for example, you see on the left, we have browse websites and write paragraphs in Notepad. They're essentially the building blocks of the applications. So we have browse websites, write files, read files, that sort of stuff. We can combine these tasks into then activities. So for example, this activity just runs a single task. 70% of the time it will run browse websites, 30% of the time it will write in Notepad. You can imagine this as sort of a researching activity where you spend 70% of your time, Googling papers, and then 30% of it writing down in your Notepad. We can then combine these activities into schedules. So the general idea is that we're trying to mirror humans here, and generally humans have a fairly fixed schedule of their day. So this person, for example, from 8 a.m. to 11 a.m., they're either doing the demonstration activity or research. And after about 11, they'll move to just doing research for the entire day. This gives us a really flexible system of we can very much craft a person's day however we want. And then for added complexity, which I really regret doing 2 years ago, but here we are. Each profile can then overwrite any value in these activities, in the scheduling of them, in the tasks in the activity. So if you wanted, I don't know, Steve to use the demonstration schedule but start at 6 a.m, you can, which is awful in the code base because the database structure gets absolutely wild. So this is two VMs running side by side. Hopefully that's running. So the one on the right is just using the browser. That's done through Selenium, which if you've ever used Selenium, you know it's not too difficult. The one on the left here is writing documents in Word and then saving them to the documents directory. You see .docs. And this is all doing it by itself. I'm going to go slightly into how you interact with Word documents in this way because it's very cursed. But the aim is that we have to let our application actually use the save prompts. We have to actually let them open the prompts and select the file to better mirror what an actual person would do. We can start these applications using like notepad.exe, mydoc.txt, but the problem with that is that that is not what a human would do. They would open the command line to do it. Well, some of us would, but yeah, you can get the general idea. On the right, they're browsing emails. They'll then save the attachments and open it in their respective viewers. Yeah, so that's a little bit of what it looks like. And the idea is that we can scale this up to 100 VMs, 1,000 VMs, and then have a whole lot of data. So, Windows automation APIs. So a lot of this program is looking at how we can interact with the UIs rather than just doing everything through the command line. So the Windows automation APIs, they're a set of APIs that can be used for accessibility purposes mainly. So the general idea is that if you have a screen reader for someone who's hard of sight, then they can have the buttons read out to them and then they can interact with that way. It's fantastic, it's great in practice. Problem is that when you don't have a human telling what button to click or listening and repeating back, interacting with them is incredibly difficult. Here's a demo of sort of what they look like. On the left, we have a folder on my PC, and on the right, we have the output of a tool called Auto IT. This is a tool from Microsoft that's meant to allow you to sort of look at the window structure, look at all the objects and how they're put together. So we can see here that these list items are the file names that are inside this folder. And so this is sort of the view you get from the automation API. This is the output that you get. So we click on the new folder button, for example. So you can see that right at the top, the name of it is new folder. We get the control type, like whether it's a button. We get lots of properties of whether sort of like Windows UI things are related. We also get stuff like keyboard shortcut. default action, a description of what it does. This looks great, there's so much data here. You think it's very, very easy to, interact with this. It is not. I use something called Python Auto, which is essentially that sort of Python to Windows API mesh. The issue with this is that this for a screen reader is really easy because you can say to the person, oh, do you want to click this button? Do you want to click that button? Problem is that when you're trying to do it without having a human interaction, you rely on things being consistent. So, for example, some of these controls will have an auto ID, which is supposed to be a unique ID assigned to the new folder button. As you can see here, it doesn't exist. This is very much the case for a lot of Microsoft applications. You'd hope that, if you have a custom application, you'd expect it not to. You'd expect all the Microsoft ones to. They don't. In some cases they do, which makes it even worse because your code is sort of littered with things that look like this. So there's an example of Python Auto's code, or out of the stuff code base, but using Python Auto. Self.app is just a reference to the Notepad process. We grab the top window of it, and then we grab a nested window with a title Notepad. We have to check if it exists because nothing is consistent. We grab 65536. Now, if I remember correctly, this is an error prompt ID. So we check if the error prompt exists, fetch all the text from it, and do some error checking. And then you can see at the bottom here that it'd be great if the no button had a consistent auto ID like 0, and yes had 1. Wouldn't that be great? But no. So very much the entire code base looks like this: of try and grab some control. Does it exist? If not, do error handling and repeat. And if your application ever updates, then you might just have stuff break because they've changed the name, the auto ID, anything like that. It's awful. Another example here is that we had an issue where we couldn't get Microsoft licensing for this project. So we essentially were using unlicensed versions of Word. If you've ever used an unlicensed version of Word, you'll find that it will load fine, then maybe 2 minutes in, maybe 2 seconds in, you'll get a prompt saying sign into Office, which makes my life really difficult because if this random prompt comes up when I'm not expecting it, there's no human there to say, oh, I'll just close that prompt, I don't need that, which makes sort of interacting with any application very, very difficult, especially when they update. Yeah, any questions?